Hello, everyone, and welcome to my session on troubleshooting slow email delivery in Outlook. My name is Nourdin Boulassel, and I'm an escalation engineer for Microsoft. The goal of this talk is that it shall enable you to follow a client request end to end. And the second goal I had in mind is that you shall be enabled yourself to identify where latency on a client call or client calls in plural can happen. And with that, we go on for the next slide, which is about a really short note about the Exchange architecture, very high level. We have a client access front end on the Exchange server, the cafe role, where all the traffic from clients go in and receive that we receive on port 443, and the client access front end then proxies that traffic back to the backend web pages running on port or listening on port 444. It might be the same server, it might be a different one, depending on how many servers you have. And note, there is no cross-server RPC in Exchange 2013 and onwards. And so what are we talking about here? The slide is not absolutely correct. You might notice here the UM router part, which is not there in Exchange 2019 anymore, but for 16, that's right. So we talk about Outlook connecting to Exchange by means of MapiHttp, going into the client access services, then be proxied back to the backend. And this all grayed out stuff is that we don't cover because it's either, well, POP, IMAP, or SMTP, nothing that we should care about here. And with that, one last word on architecture. Where can you trace or where can you collect data, meaningful data? That's one thing. Here on the client, of course, then you have on the client access services in the IIS log on the front end, the HttpProxy log. Then, of course, when it reaches the backend services, again, it goes to IIS, so you have another IIS log and the backend protocol logs. And then, depending where the traffic for that client request actually goes, is it really store? Is it Active Directory? You need to collect data on that side. One thing to note here, I've not mentioned the HTTP error log that is usually in the Windows System 32 log files directory, because we assume that the request in question is maybe slow, but not failing. So if it were failing and be recorded to the HTTP error log, you'll unlikely see a lot of traffic in the other logs. Then let's start with data collection. Number one, the client. Of course, you can enable troubleshooting logging within Outlook in options, advanced other. This will create an ETL file, and it will contain lots and lots of very detailed debugging information. And this was originally designed from Outlook development team for their own troubleshooting. So you can collect the data. It goes into the user's temp directory from of his environment. But to analyze, there's only an MS internal tool capable of doing so. A sample line from a screenshot I can show you nevertheless here. As you can see, the timestamp really goes down to the 100 nanoseconds time frame. You would see a request ID, a connection ID, a possible latency, and a request header. And we could use that information to start with the data collection and where the client starts with its call. And but as I said, to analyze, you'd need to open a request with Microsoft support to get that data analyzed. More convenient maybe is there is a third-party web debugging proxy available from Telerik called Fiddler that will actually act as man in the middle because it has its own certificate that you need to trust, and then it can decode everything that's going down into the fiddler, and then it will pass on the traffic on to where it should actually go to. Useful also for Exchange Online troubleshooting, because all of the other data that we are going to see and talk about in the rest of this presentation is not available to you. And so to get a first-hand experience how fast or slow something is, you could use this tool. 2 tips here. You could add the 2 more columns to the default view. That's the overall elapsed that I added here, and the server think time. As you can see, this one is in hours, minutes, seconds, and fractions, and the server sync time is in milliseconds. There is difference in the 2 columns. That really means overall when client sent the request until client received it, whereas the server think time is the difference between when the server got the request and the server began to submit the response. One thing to note also on the very first place is a call, a click on the client side, an action there might not be just one line here or one line then further down in your IIS logs or proxy logs or wherever. It might consist of maybe dozens or hundreds of entries. So a slow request or slow response might be really just one line, one entry, but it might also be the accumulation of the many single entries that just add up in time. Now, what you can see in the headers analyzer in Fiddler is here on the left-hand side, a sample request. You would say a X request ID, typically some unique GUID, and a sequence number here, 28, that will continue to increase on each call. So the next call would be 29, 30, and so on. Then you'd say the X request type, here an execute. These are the ones, the executes, I mean, that keep us busy doing something on the server side. And you'd also say the user identity, some chap called ckirk@contoso.com. And there's a lot of other stuff. The response then, when it's coming back, has a new line, a request ID that was added on the server side. And note that one, because using this request ID, you can then search on the server side for each entry in one of the logs, be it IIS, be it proxy, be it backend logs. What else do you get? You get the backend server. So what was I actually talking to? Where's my mailbox? Where's that mailbox that I was accessing here? You'd also say the front-end server that we were communicating directly. There might have been a load balancer, but you can see that this one definitely goes in here for a server called EX19B. And then you see again the X request ID with the sequence number of 28, and of course, X request type. If you think this is not enough for you to troubleshoot your issues, there is add-ons available for Telerik, either on their website, or Microsoft also does provide a inspector for Fiddler. It's called Office Dev Office Inspector for Fiddler, and it allows you to decode the MAPI body part of such a request, if you really want to go that deep. And with that, we already are going to leave the client side and start on the server side. As I said, we are going to hit an Exchange server on port 443 on the front end on the cafe role. And so we will be logging each and every request coming in into the IIS log. And I may be it active sync, auto discover, and all the others will be going there. But pop IMAP and SMTP not at HTTP, so will not be logged there. Unless you installed or redirected these files somewhere else, this will be here the default location. Also note that MAPI has two different flavors, one called EMSMDB, one NSPI. EMSMDB is when the request is going to the store side. EMSMDB is the Enterprise Messaging Server Message Database, a very old name. And NSPI is the Name Service Provider Interface, also known as Address Book. As you know, there is a header line available in each of the IIS logs, highlighting here the time taken. If you need extra fields, you can add them manually. Normally, all these fields and the values are described in our documentation from the IIS. And a typical line could look like this. You may notice that again, it's this within the CS URI stem that we see this GUID with the sequence number of 28. Oh yeah, it's that execute again, and here you see here it's called cafe request ID and all the other information. And again here, so we have 200, everything's okay, no error, and it took 90 milliseconds. But I come to that in a minute again. So the same here, just displayed in the table. And what can you take out of that? Of course, date and time. And note that the time is not when the request arrived on the IIS, but when the request has been successfully fulfilled. So the response has been sent back to the client, and, very important, and the client has acknowledged it has received the response. So in other words, you'll have the network time added in that timestamp. Then of course, yes, it's a post. URI stamp goes for MAPI EMSMDB, so it goes down to the store. In the mailbox ID, you see in the GUID of the mailbox attached with the domain name. And here in the client request info, you'd see all the GUIDs that make that request identifiable. So if you know the user, if you know the GUIDs, you will find it here. And that's how you can make the flow of that request going through. You see the user agent, you see, okay, it's an Outlook client. And again, the rest of these values here. And with that, we already can go further down into the cafe logs from Exchange. So that means now we have entered really Exchange, because IIS is IIS, but now here HttpProxy logs, that's when the proxy handler of Exchange is going to take over, and we are going to log our own stuff now. And what do we do here? Well, we are going to log any of the incoming requests that need to be authorized, authenticated, and then proxied to some backend server for further processing. Typically, if you installed it in the normal way and not modified the location, it goes into logging HttpProxy, and each of the protocol has its own subdirectory. So here in MAPI, you will see all the calls from a MAPI HTTP client. Here, be it EMSMDB or NSPI, it will be all going into MAPI. For 2016 and 19, the header logs are all the same, and all the content is the same, so there is no difference. So if you have something to query on 16, you can reuse it on 19. I've highlighted in red, I think, for me, the most important ones when I look at these data: the date time, a request ID, the client request ID, authenticated patient type. If the client is authenticated, who it is, target server, which is the backend server that we are going to proxy that, then the backend processing latency, and the total request time. In light blue, you see all the other latency values that might be added. That's not the case in Exchange on-prem, but so some values may stay empty, but that's normal. And so you'll ask, what shall I look for here? Yeah, first of all, either you use some tool like logparser to aggregate your data, or if you actually really know it was in this and that file, I have the ID, okay, just go ahead, use maybe Excel or your favorite editor to look into the file. But I suggest you definitely look for the date time for the target server and the two latency values, the backend processing latency and the total request time. The total request time is the total amount a request spent from entering the proxy handler and until the response came back from the backend server and we hand off the response. So that's total request time. Whereas the backend processing latency is only and merely the time when we handed off the request to the backend and we received the response. And the timings here, all of the latency columns are in milliseconds. And now, depending on your specific use case, if, for example, the backend processing latency is small, but total request time is large, I mean, like backend processing latency in maybe 50 milliseconds or 10 milliseconds, but total request time was like a second, then I suggest you check on latency values for the pipeline latency and or the proxy overhead, because it means that somehow the request that was coming in was queued inside the proxy handler for some reason. And one of the reasons that I'm aware of is when the call got down to authentication, but the authenticating domain controller had an issue. Whatever it was, whatever it is, that's your place then to look next. Here is a sample that I passed out using Log Parser Studio for the very named, you may see, or we conceal this request ID again, and the X request ID with the sequence number of 28 for the timings. And you see here total request time is 40. And if you remember in IIS log, it was more or less about the same. But on the client side in the fiddler, it was more or less, I think, 90 milliseconds. So somehow we spent 40 to 50 milliseconds somewhere on the network. Is this reasonable? In this case, yes, because the client was here in the office, whereas the Exchange server where I collected that data was somewhere located in some Azure environment. You can distinguish between EMS MDB and MSPI calls by checking out another header value, not seen here, URL stem, because that one goes really /mapi/EMSMDB or /mapi/NSPI. And again, the request type execute. You might see others here, but it's the execute that we should mainly concentrate on. And now that we know where we should proxy the call, then it will be hitting one of the backend servers in your environment, running on port 444. For the logs, for the IIS logs, the same applies we've seen on the front end side. Everything's going in here, active sync, auto discover, whatever. It uses, of course, the same header line, and the default location is typically the W3 SVC2. But actually, for MapiHttp EMS MDB calls, you can't make a lot of sense out of that because we just don't have any data that we could correlate for these calls. Here's a sample from one of these backends. And as you can see, oh yeah, it's MAPI EMS MDB. Yes, I see it's for that mailbox, A9 something, but then that's about it. Yes, we see it's port 444, anonymous. That's normal, that's expected value here. And yes, we see it's that client. Everything's okay and fine with the 200 timing, 20, 13, and 23 milliseconds, but just no way to correlate which of the calls I'm really I was interested in. It might be different if you know that it's just one call that took like, I don't know, let's say 15 seconds, then you would see maybe something like 14,000 milliseconds here. Yeah, but if there was two of these calls, just no way in doing so. So I personally don't collect these logs and I don't look at the IIS logs on the back end. I use really then more on the protocol logs that are way more interesting because they provide another really meaningful entries for you to analyze and identify, make it identifiable where the latency occurred. And now for the MapiHttp, we have two different log locations here. EMS MDB for mailbox that goes into logging MapiHttp mailbox, whereas address book goes for logging MAPI address book service. And note that now from here on, that's the latest point where Exchange is handling incoming requests as a HTTP stream. And from here, it has to either go down into its local store, or if it's an SPI call, an address book call, it will be proxied to a global catalog server. But first, let's look at what these logs look like. For EMS-MDB, I don't show you the header because not very interesting. What you see here, a date time, then you can see a request ID, the GUID, and that makes it identifiable, and so you can really know, yep, that's the one I've seen in a proxy log. Yes, that's the one I've seen on the IIS, and maybe on the fiddler trace that you collected. And there's a few other entries down here. I'll come to that in a second. And a similar entry, if there was an address book query, looks very different. Starting with a hash fields value. If you are familiar with the Outlook Anywhere RCA logs, then yep, that's coming from that side, and that pretty much looks the same. And starting with Exchange 2019 CO12, we also add an entry here in the NSPI logs that tell you which global catalog we were connected and talking to, at least for these calls where this information was available. For Exchange 2016, sorry, we didn't backport that, as Exchange 16 was already in extended support. And what shall you look here? So, of course, date time. Again, always UTC. In all of our logs, we use UTC. And the big difference here is in the protocol logs, we do enter the time here when the request entered the handler. So that's on the contrary as you've seen in the IIS and the proxy logs. That was when the request was, or the response was finished and delivered back to the client. Here, for whatever reason, we write down the time when the request entered the system. So that means if you had a long-running request, for example, not an execute type, but a notification wait, then you might say that this entry somewhat fell out of time because all the others have like an increasing number, but that one is like a minute back in time. Yes, that's okay, because we note and write down the time when the request enters the protocol handler. Then, of course, you should look at the request types. You should be interested mainly in executes, unless you have an issue where log-on is slow, then of course you want to look at the log-on types. Don't look at notification wait. These are expected to be possibly huge in time. Huge means minutes. I've seen values up of about 10 minutes or so, and but that's okay. You need to know that a notification wait is nothing else but the client registered for a notification when a certain event has become true, and that is then being sent back to the client to notify him, yep, here is your data that you requested, like, I don't know, 5 minutes ago. And you also need to note that these notification waits are non-blocking for the Outlook user interface. So if you see a very high value, check if the request type is notification wait, and then simply ignore it. You should also look at the authenticated user email and or act as user email. If there is difference, then you know might be a delegated scenario or something like that. You can validate the mailbox ID that is being accessed, because it could be the user's email mailbox, it could be a delegated mailbox, it could be a public folder mailbox. Check the Exchange GUID, resolve it on your Exchange server, and you'll get to the mailbox that is then accessed. Very interesting, the client mode. One for, I don't want to say bad old, but for online mode, and 2 for cache mode. And then, of course, look at the total request latency, again, unit in milliseconds. And if that's really high, yeah, there might be something going on that server related to that specific database where this user's mailbox is located. It might be, if that's really high, it might be worth looking into what the user is actually doing. Is he issuing a filter request? Is he working on a folder with super many items? Well, go back to the user in question and ask, what were you doing at that time? Because it makes your life a bit easier to understand. And here again, the very same execute with the sequence number 28 that we are going through all the time. And this read 27 right in front of the word unknown. That's the total request latency for that user, for that mailbox. And as you can see here, with that one in front of the word negotiate, that's the client mode. So one online mode that I explicitly used here to collect some data. And if you want to know what the user was doing, then these light blue numbers in square brackets show what it is. That's the remote operations, the ROP IDs, like 18, 21 in decimal, yeah, the notation. And we have specified and provided each of that in a public document called the table of ROP IDs. It's somewhere in the Exchange server protocols, and I have it noted here in the PowerPoint that goes with that slide. Of course, you can also look at the generic info, starting here with CPN, but actually to make really something out of that, all the abbreviations here, well, MAPC, so MAPI call, how many calls are there? But that's not very well documented. To be honest, it's not documented at all. If you're at that level, you might need to talk with us from support. And for switching over now to briefly to the address books, as I said, we're starting with CU12. We provide the GC name where possible. That entry that I show here, unfortunately, was with CU11 at that time. And as you can see, it was an NSPI bind. It tells you what it is. and also the timing. One word here about timing. If this is a high value, then most likely this is not an issue on Exchange itself, but rather an issue with the domain controller, the global catalog that we talk. And another word here, once the request goes off to the global catalog, this is by no means LDAP. NSPI calls are going down as an RPC call to the global catalog. So you don't want to place any firewalls in between that interfere with that traffic. I've seen that in the past. No fun troubleshooting that, and definitely no fun for the clients because they might have issues in really getting down to the address book or entries there, and then it hangs. And just don't do that. So now, with that said, we are through with the protocol side, with the HTTP side, and are going down to the store here. In the past, we used to have the Exchange User Monitor, but unfortunately, that has been removed from the Microsoft web pages. If you are keen in getting that, use the web.archive.org. That's still available there, but I personally haven't used it for many years now. As a replacement, you can use the PowerShell commandlet that we ship with Exchange to get store usage statistics, which will provide an output similar to this here if you were requesting that for a single user. There are 3 different types available. One is a mailbox identity, or second, database, or third, a server. And it will collect the data from the respective store worker process from the last 10 minutes and will provide you with information about this user's activity inside the store. And most of the times when you are having issues, you might also need to look at the performance log then to further dig into the cause of why is this call or these calls why are they slow? You don't need to set up special performance tracing. Exchange does that for you. There's a lot of counters, like depending on how many databases you have, I guess, and I would assume at least 18 to 1900 or more. We sample with 1 update per minute, and we keep that running 24/7. And to not write your disks full with that diagnostic data, we have an automatic job in place that removes aged files once the total size exceeds 5 gigabytes, typically running once per day. So you might need to speed up to keep the data for further analysis if needed. 1 word of the location, again, it goes to logging diagnostics, daily performance logs. And for that, you can say, that's a sample from a customer. What to look for here is hard to say because number 1, you need to know where and what is normal to make a distinction what is not normal. Here in that screenshot, I think it's obvious that at some point in time, a few counters here simply jump to the ceiling and show an abnormal behavior. In general, I can just say, when you know what process you are talking about here, it's certainly some worker process, the MapiHttp ones, of course, and so you'd look into these processes. Are they going high in CPU? Are these processes consuming much time in garbage collection, etc., and so on. But for a plain start to monitor your health, you still can use those from the Exchange 2013 performance counter. And if the daily performance log is not good enough for the special problem you need to troubleshoot, you might also need into the Windows Performance Analyzer, formerly known as XPerf, and for that special tool, very rich, very deep, you should really have a repro in place, because more than 30 to 60 seconds is usually not very useful, as the file that is going to be collected there is just going into the gigabyte range in that 30 to 60 seconds, depending on the number of objects and configuration of the recorder that you choose. Seen that the customer collected 2 minutes worth of tracing, and it was a two-digit gigabyte file size, and that's just no fun analyzing. Some links for you: the performance toolkit, the recorder, the analyzer. If you want to see some working examples how to, don't mind and head off for the defrag tools. And with that, I conclude we can switch over to a Q&A. I hope this content will then be shared. And what I'm going to share with you is a simple diagram that goes for such a MAPI call from the client through the front end side, the back ends, and what data to look for, and where it is. That's one thing. And the other thing I'd like to share is a few simple latency checkers using Log Parser Studio for IIS, HttpProxy, and MapiHttp. You can download Log Parser Studio from that location. And with that, I'd like to thank you for joining the session. Wish everyone a great day ahead. Thank you.